Where exactly is the limit of the human body? Extreme heat and searing pain, crushing gravity and starvation, suffocation. Today we're counting down 10 ultimate tests of the human body, watching how life struggles and collapses at the edge of destruction, and how it can still unleash astonishing resilience. 1. The limit of acceleration. Pure physical force, ruthlessly crushing flesh and blood. When fighter jets climb sharply or pull tight turns, pilots are subjected to intense positive G-forces. Blood is violently pulled toward the lower body, 4 to 5 G. The retina becomes deprived of blood and peripheral vision fades. This is the classic visual symptom known as gray out. When acceleration increases to 5 to 6 G, blood flow to the brain drops sharply, causing loss of central vision. This is what people call blackout, and it's a severe warning of brain hypoxia. If the G-force continues or lasts longer, the next step is loss of consciousness. Highly trained pilots, using G-suits and anti-G maneuvers, can briefly withstand up to 9 G, but beyond 5 seconds, they will still black out. Negative G is even more dangerous. During steep dives, inverted flight, or sudden deceleration from high speed, negative acceleration is generated. Inertial force drives blood rapidly toward the head, causing pressure to spike in the brain and eyes, leading to congestion and swelling. The retina becomes overfilled with blood. What the eyes perceive turns red or pink, until the entire field of vision is flooded with red. This visual disturbance is known as red out, compared to blackout caused by positive G. The human tolerance for negative G is much lower. Even a few seconds can trigger red out. The ultimate human acceleration limit was tested in 1954, when U.S. Air Force Colonel John Stapp, studying ejection seat survival, rode a rocket sled and endured a staggering 46.2 G, though it lasted only 0.04 seconds. In that instant, an invisible hammer slammed into his body. His eyes bulged and ribs fractured. Multiple blood vessels ruptured and his retina detached. In the end, with special restraints and sheer willpower, he survived, becoming the ultimate record of flesh and blood resisting pure physical impact. To the limit of heat tolerance. Do you think a human can survive in a 95 degrees Celsius environment? It sounds almost impossible. But in 1775, British scientist Charles Blagden and his colleagues performed a world-shocking experiment. They decided to step into a chamber heated to 95 degrees Celsius and stay inside for a full 10 minutes to experience firsthand how extreme heat pressures the human body. They even placed raw steak and eggs inside the oven as a comparison to see what fate awaited living tissue at such temperatures that seemed completely unimaginable. The moment the experiment began, heat waves surged like fire, devouring everything around them. The steak rapidly denatured under the heat, its proteins nearly cooked solid. Yet, unbelievably, the experimenters survived. In this inferno-like environment, when they walked out, they had lost several kilograms of body weight, mostly from water loss, but their core body temperature stayed below danger levels, and vital functions remained stable. So how was this possible? The answer lies in the body's powerful self-regulation, sweat evaporation. When external heat nearly overwhelms every cell, the body releases heat through the evaporation of sweat. For every liter evaporated, about 580 kilocalories of heat are carried away, allowing humans to barely survive extreme heat. If core temperature stays above 42 degrees Celsius, proteins undergo irreversible denaturation. Their precise, folded structures collapse, and biological activity is lost. This shuts down cellular energy production, destroys membrane integrity, and breaks critical metabolic pathways, leading to massive cell death. This is the deadliest form of heat illness, heat stroke. The experiment clearly proved that in dry, low-humidity conditions, efficient sweat evaporation can temporarily prevent core temperature from reaching lethal levels at the cost of rapid dehydration. 3. The limit of pain. Pain is the nervous system's warning signal, an alarm that danger has arrived, and when it becomes overwhelming, pushes you to the brink of collapse, while individual tolerance varies. Clinical medicine confirms that when pain exceeds physiological limits, it becomes a tool that shatters willpower, like a form of torture. Pain is commonly rated on a 10-level scale. Levels 1 to 3 are mild pain. This level stays within everyday human tolerance, usually minor skin or superficial tissue injuries, like small scrapes, mild headaches, or muscle soreness. These may be uncomfortable, but they are far from the body's limit. Moderate pain is levels 4 to 6, when discomfort escalates into dull aching, sharp or throbbing pain. It begins to limit normal activity. Toothaches, joint strains, or stomach cramps fall into this range. Pain penetrates deeper tissues, triggering stress responses. Severe pain is level 7 to 8. At this stage, pain becomes a violent physiological storm. Kidney stones, severe fractures, or nerve injuries belong here. Every surge feels like blades slicing nerves. The body reacts violently. You almost lose control of your body. Pain dominates your consciousness. Normal thinking and decision-making collapse. Fear and helplessness spread rapidly. Extreme pain is classified as level 9, the ultimate hell the nervous system can endure. Pain becomes an inescapable monster, ripping through every nerve and cell. Trigeminal neuralgia is widely known as the worst pain, described as lightning-like. Knife-cutting agony in the face. Even light touch speech or cool air can trigger it. At this point, pain goes beyond a signal and becomes a constant destructive experience, often accompanied by a sense of impending death. Level 10 is lethal pain, the final boundary of human physiology. Every nerve is pushed beyond its limit, leaving you with almost no bodily control. Pain is no longer momentary, but an endless, relentless torment. The toxin of the Gympie plant is considered the ultimate example of level 10 pain. In 1970, an Australian soldier used Gympie leaves as toilet paper and touched its lethal toxin. Instant burning and electric shock sensations raced along his nerves. This endless neural torture destroyed his sanity within moments. He ultimately shot himself. At that moment, death was not fear, but the final mercy before nerves burned out. For the limit of starvation. Starvation is the body's energy failure alarm and the beginning of systemic metabolic collapse. When external nutrition hits zero, the body activates a stepwise survival program, burning itself to stay alive until all reserves are gone. On the first day without food, the body rapidly consumes glycogen stores to maintain basic metabolism. You'll feel hunger, weakness, and anxiety. But daily life is still possible. The damage is not yet critical. After 5 days without food, glycogen is nearly exhausted. The body switches to fat as its main fuel. Entering ketosis, hunger becomes far more intense. Fat stores are rapidly depleted. Body weight drops steadily. The immune system weakens. Thinking slows. The body enters a low energy state. By day 10, fat reserves are depleted. Muscle protein becomes the final fuel. The severely weakened body begins to fail. Organ failure appears. The immune system collapses completely. The brain slips into cognitive fog from glucose loss. Hallucinations emerge. If fasting exceeds 30 days, muscle and fat are fully consumed. The engine of life shuts down. The body can no longer sustain itself. Fatal electrolyte imbalance leads to death. The longest recorded human fast was achieved by Scottish man Angus Barbieri. Between 1965 and 1966, he completed a 382-day fast, weighing 207 kilograms at the start. He chose fasting to lose weight. His only intake was water, tea, coffee, and vitamin supplements. The entire fast was medically supervised, ensuring basic electrolytes and vitamins were maintained. Over those 382 days, his weight dropped from 207 kilograms to 82, a total loss of 125 kilograms. This process placed extreme stress on his body. His immune system was damaged, energy reserves nearly exhausted, cognitive ability declined sharply, and mental stability suffered. 5. The limit of breath holding. Breath holding is the body's final defense against hypoxia. When breathing stops, blood oxygen reserves can sustain the brain for only 4 to 6 minutes. Beyond that, neurons begin to die irreversibly. Untrained people usually last 1 to 2 minutes, but through extreme physiological adaptation, elite freedivers pushed the static breath hold record to 24 minutes and 3 seconds. The breakthrough relies on 3 survival mechanisms. 1. The mammalian dive reflex. When the face contacts cold water, the vagus nerve is instantly activated, dramatically slowing heart rate. Peripheral blood vessels constrict, redirecting oxygen-rich blood to the heart and brain, preserving core function. 2. Deep metabolic suppression. Through meditation and relaxation training, freedivers drastically lower metabolic rate, reducing oxygen consumption across the body, entering a low-energy state. 3. Maximizing blood oxygen storage. Before competition, divers perform controlled hyperventilation and may inhale pure oxygen, raising arterial oxygen saturation near 100%. At the same time, the spleen contracts, releasing stored red blood cells, increasing circulating blood volume by about 10%, greatly enhancing oxygen transport. However, this extreme challenge carries deadly risks. The brain suffers severe hypoxia near the end of breath hold, with potential neuronal damage. More dangerously, untrained people copying hyperventilation before diving face one of the deadliest risks. Hyperventilating before a dive rapidly lowers carbon dioxide levels. But carbon dioxide drives the urge to breathe. When it drops too low, the respiratory drive is suppressed. During ascent, divers can black out without warning and drown. This is one of the leading causes of recreational freediving deaths, causing dozens of tragedies worldwide every year.